Welcome back. We're still talking about properties of logarithms. Remember that the third property of exponents were about what happens when exponents get raised to two other exponents. So that's going to correspond to the third property of logarithms. And we'll explore that with this example that I will just make up. We'll say log base, I don't know, sure, log base 4 of 64 to the 6th power. I don't know what 64 to the 6th power is, but it's probably enormous. Well, let's see. 64 is 2 to the 6th. So 2 to the 36th should be about 8 billion. Somewhere on the order of 8 billion is how big this number is. I'm not going to find out exactly what it is because I have other things to do with my day. More important things, like taking a nap. So, instead of trying to figure out what this is and then trying to figure out the log base 4 of it is, I'm going to do the same thing I did to the other problems. I'm going to rewrite this as a power of 4. As a power of 4, this would be, no 6's involved yet. This is 4 cubed to the 6th. Now we can use a property of exponents to multiply these guys. This is the log base 4 of 4 to the 18th. And as usual, I'm hoping we can pretty much just establish that that's 18. So if I try to do this separately, I know that the log base 4 of 64 is 3. If I want to go from 3 to 18, which I know is the correct answer, I have to multiply by 6. So here's what's kind of different between this one and the other properties we did. With the other properties, we took the business inside this logarithm and we split it into two logarithms. So like when we had the logarithm of a product of two numbers, we split that into the logarithm of the first number and the logarithm of the second number. So there were two logarithms involved on the back end. Here I don't have that. Here I'm taking the business on the inside of that log and I'm splitting it into two pieces, but only one of them has a log. The 64 still has this log attached. The 6 from up top doesn't have a log attached anymore. It's just going to come down in front and be a coefficient. So here's what this one looks like symbolically. The log base 4 of x to the y, or no, let's call this b. Log base b of x to the y equals y times log base b of x. Again, with the other properties on the back end, you had two logs. You had a relationship between two logs. It was either the sum of two logs or the difference of two logs. Here we don't have that. Only one piece still gets a log. The y, the former exponent, no longer has a log. It's just a coefficient. So when I write this down, I'm going to try to reflect that. I'm going to say, this is pretty easy. This is exponents inside. I'm going to call this coefficient multiplication outside. And when I do this in examples, I'm just going to say bring it down. Bring the exponent down in front, because that's kind of what happens. You take the 6, you bring it down in front. This is, what do I want to say? Yeah, this is 6 times the log base 4 of 64. Take the exponent, bring it down in front as a coefficient. So this is the third property. I'm going to run through a couple examples of how you're going to use these properties on homework and test and quiz questions. And then we'll be done with this section. So, on a test or a quiz, you might get something like log base 3 of, we'll say, no, not 9. Log base 3 of 27 x cubed over z to the 5th. And a homework question like this will ask you to expand, which means it's asking you to write this as the sum or difference of as many different log pieces as possible. So we're going to split this up. I have division in here, so I can right away split that up into 27x cubed minus the log base 3 of z to the 5th. So the division inside became subtraction outside. Now I have some multiplication I can deal with. So we'll call this the log base 3 of 27 plus the log base 3 of x cubed minus the log base 3 of z to the 5th. So this is using the subtraction piece, division into subtraction. This is using the multiplication into addition. There's one more property I need to use before I'm finished with this. Well, first of all, I know the log base 3 of 27 is just 3, so that's not really a property, that's just doing a log. But for these two pieces, I need to take the exponent down in front. Exponents inside are coefficient multiplication outside. So this 3 up here comes down in front, the 5 there comes down in front. So believe it or not, these two expressions mean the exact same thing. As a single log, this looks like the log base 3 of 27x cubed over z to the 5th. As a expanded thing, this is 3 log of x, 5 log of z. So that's an example of how you expand these things, which will be part of the homework. One thing I want to mention quickly about expanding is that if there's a second piece down here, like a y, both the z piece and the y piece need to be subtracted because they're both dividing this. So if you expand this one with that y there, 27 plus x cubed, because this is multiplication, minus the log of z to the 5th, it has to be minus the log base 3 of y as well, because y is also dividing. Anything on the denominator gets subtracted, anything in the numerator gets added. This is positive, negative, negative. So keep that in mind as you do these problems. That will help you out. The other kind of problem we're going to do in this section is about condensing. So if you have something like the log base 8 of, well, let's say 3 log base 8 of 4 minus 4 log base 8 of 12. No, let's say x. Yeah, we'll make that an x. The homework questions will ask you to condense these problems. And to condense them, we basically have to go through that whole process backwards. Instead of starting with one log and making it into a bunch of pieces, we have a bunch of pieces, we want to make this into one log. So, we're going to start by putting these coefficient multipliers in as exponents. So this will be the log base 8 of 64 is 4 cubed minus log base 8 of x to the 4. Now, at this point, some of you may think, well, that's just 2. And it is, but that's not what I want to do in part of this condensing thing. If I want to condense this, I want it all to be 1 log. So both of these are log base 8, so I need to turn this subtraction into a division. So we'll say the log base 8 of 64 over x to the 4. This is how I want this written as a condensed logarithm. So we're going 2 ways. We're taking 1 log and we're stretching it out into many different logs. We're going to take many different logs and we're going to compress them into 1 log. That's pretty much it. There's plenty of homework problems that you can use to practice on, so that when we do a quiz on this stuff, you are well prepared to ace that quiz. And thanks for watching. We'll see you for the next videos.